entanglement. Quantum entanglement occurs when two particles become connected in such a way that when the property of one particle is changed, an instantaneous change in the property of the other particle occurs. Entangled particles have the opposite properties or states. Particles have a property called spin, and the particle will either be spin up or spin down in any given direction. When two particles are entangled and their spins measured in the same direction, one particle will be spin up and the other particle will be spin down. According to quantum mechanics, a pair of entangled particles could be separated by an entire universe, and when the state of one is measured and its superposition collapsed, it would immediately collapse the superposition of the other particle, and measurement would indicate that it had the opposite state of its entangled partner. So in this example, particle A and B are entangled and separated by an entire universe. They are not measured and have the superposition of being both spin up and spin down at the same time. When particle A is measured, its superposition is collapsed and it indicates spin up, and as particle B is entangled with particle A, its superposition is also collapsed and it indicates spin down. Quantum mechanics seems to say that entangled particles can communicate with a speed faster than the speed of light, something that Einstein's theory of special relativity ruled out. Einstein called this phenomena spooky action at a distance. Einstein was not impressed by the explanation given by quantum mechanics to describe the behavior of entangled particles, and he actually offered up his own alternative theory. He said that when the particles were entangled, it was decided what states they would each have when measured in any given direction, and there was no communication happening between the two particles when they were measured after they had been separated. According to Einstein, the particles didn't have some mysterious superposition of being both spin up and spin down until measured, but rather at the point of entanglement it was decided what spin one would have and what spin the other would have in any direction it was measured. Einstein's explanation versus quantum mechanics explanation. Professor John Bell actually came up with an experimental way to test whether quantum mechanics or Einstein's more classical explanation worked when it came to explaining the results entangled particles gave when measured for their spins. What emerged was that Einstein's explanation broke down, and the predictions made by quantum mechanics were consistent with the experimental results. The experiment proved that the spin of the particles were not defined specifically in all directions of measurement when the particles were entangled, as Einstein had theorized. Introducing quantum tunneling. In a phenomena called quantum tunneling, it has been observed that particles have the ability to cross barriers they shouldn't be able to. The reason for this is down to the particle's wave function. Let's use an example. This particle here shouldn't have the energy to be able to cross this barrier, but it can, and that's down to its wave function. Even though the probability of finding the particle on this side of the barrier is low, it is not zero, and the particle can indeed tunnel its way to the other side of the barrier. Quantum tunneling is responsible for nuclear fusions in our Sun. In the Sun, hydrogen atoms fuse together to create helium and other heavier elements, releasing huge amounts of energy in the process. The hydrogen nuclei consist of positively charged protons, and as like charges repel each other, fusion only occurs when a huge amount of heat is applied to overcome this barrier and force the protons together. However, the Sun isn't hot enough to give the protons the energy required to overcome their repulsion. The reason why the protons can overcome the repulsion between their positive charges is down to quantum tunneling. Owing to the proton's wave function, there is a small probability that some of them will tunnel across the barrier and fuse with the other proton, creating heavier elements and thus fueling the Sun. Why do we accept quantum mechanics? The predictions of quantum mechanics have proved so reliable that we cannot ignore the experimental evidence that corroborate the theory. The entire electronics industry is built